Hello everyone, happy to see you here. Welcome back to my channel Higher Mathematics. Today we have great algebra question 2 to the power k equal to k to the power 32, and we need to solve this question for k. So if you have your solution, your answer, your assumption, your thoughts, you can also write it in the comments below. It will be really interesting to check our answer, to check our solution in the end of the video. Okay, so first of all, let's rewrite this question right here in the new line. So we need to solve this one, 2 to the power k equal to k to the power 32, and we need to solve this for k. Okay, so the first thing, what are we going to do? We're going to split our variables on the left side and our constant on the right side. So that's why we want to raise our equation to the power 1 over k. Yeah, right here we're going to raise to the power 1 over k. Let's do it. So we're going to raise our left side 2 to the power k to the power 1 over k, and we raise our right side k to the power 32, and we raise to the power 1 over k. So I hope you understand. We just raise both sides to the power 1 over k. And right now on the left side we can easily cancel this k because we have the next expression. We have 2 to the power k times 1 over k. This is our algebra property, so we need to multiply it, and we need to multiply on the right side. So we have k to the power 32 times 1 over k. On the left side we can easily cancel our k right here, so we have only 2 on the left side. And on the right side, when we multiply our numerator, not numerator, like powers, 32 divided by k. So we have k to the power 32 over k. So we hope you understand this first step. So what are we going to do next? Right now, let's raise both sides to the power 1 over 32. This is our next step. So we're going to raise both sides to the power 1 over 32. Because as I said before, we just want to split our variables on the one side and constant on the other side. So we're raising both sides to the power 1 over 32. We have 2 to the power 1 over 32 and equal to k to the power 32 over k and raised to the power 1 over 32. Okay, so this on the left side we can leave without any changes because this is our our constant, 2 to the power 1 over 32. And on the right side we can easily cancel this 32 because when we multiply our power we can easily cancel this 32 because this one is in the numerator, this one is numerator, so we can easily cancel it, and we end up with the k to the power 1 over k, 1 over k. And for better understanding our last step in this part, we can change these positions because we prefer our variables on the left side. So k to the power 1 over k equal to 2 to the power 1 over 32. Okay, so this is our first step. As I said before, we just want to split our variables and our constant on the right side. Okay, so what are we gonna do next? Right now there's another tricky move. Okay, so let's start on the left side. So we have k to the power 1 over k equal to 2 to the power 1 over 32. Right now I want to multiply, so I'm talking about this power. I want to multiply this power by 2, so we have 2 and 2. So basically we have 2 to the power 2 over 64. 2 over 64. Right now, I want to split this power. I want to write this 2 over 64 as 2 to the power 2 times 1 over 64. Okay, and right now, we need to learn about really interesting property. Everyone knows this property. When we have a to the power x raised to the power y, this is equal to a to the power x times y. So we already had this property exactly in this case and in the previous part, but in the same way, when we have a product, we can easily go back to the beginning. So basically, when we have a product, we can write these two, exactly in this case, this is our x, we can write in parentheses. So we can write 2 to the power 2 in parentheses to the power 1 over 64. So I really hope you understand this step. It's extremely important for you to understand this line, because right now we can easily write that k to the power 1 over k, so k to the power 1 over k is equal to 2 square equal to 4. So we have 4 to the power 1 over 64. So why do I solve this question like that? Because I see the same structure on both sides, and I want to get in closer and closer because we have k right here, we have k right here, we have 1. So basically we have the same structure, so this constant need to be the same. That's why we just repeat this step once more. So we have 4 to the power. Right here we multiply it by 2, so we have 2 over 128. Okay, and right now we split it, so we have 4 to the power 2 times 1 over 128, and we write the same thing, 4 square, so we have 4 square 16, so or let's write like that, 4 square to the power 1 over 120, 1 over 128, and 4 square equal to 16, so we have this line, k to the power 1 over k equal to 16 to the power 1 over 128. Okay, so I hope you understand this step, and right now we can see that these two constants are not the same. So right now let's do the step once more. So we have 16 to the power, when we multiply it by 2, we have 2 over 256, so 2 over 256 equal to 16 to the power 2 times 1, so we split it to 256, and right now we use this same property, so we write this as 16 square to the power 1 over 256. And right now let's look closely what we have, because 16 square equal to 250 and 256, so basically we have k to the power 1 over k equal to 256 to the power 1 over 256. And right now, what a beauty. Let's look at this expression, because we have the same structure. We have 1 we have the same fraction, 1 over k, 1 over 256, but moreover we have the same constant, so only one case, only one root from here, k is equal to 256, because when we plug in 256 we have absolutely the same symmetrical expression. So k is equal to 256. This is our root to this question, and right now let's try to check it. So let's check our 256. So our check, 2 to the power k equal to k to the power 32. So let's check k equal to 256. So for k equal to 256, let's plug in it. So we have 2 to the power 256 equal to 256 to the power 32. Okay, so how can we simplify it? Let's leave like that without any changes. Let's leave our left side. So we have 2 to the power 256 equal to 256 can be written as 2 to the power 8. So we have 2 to the power 8 raised to the power 32. So that's why we have 2 to the power 256 equal to 2 to the power 8 times 32. So 8 times 32 equal to 256. So 256, absolutely the same expression, so we don't need to raise this 2 to the power 256. So we have absolutely the same expression on both sides. So this is our answer. So let's write our answer to this question. Our k is equal to 256 is a correct answer, is a correct root. And few thoughts about this question, because first of all I want to say that this is not like a solution. I want to say this is not like an algorithm for this question. This is not a solution in general, because for example if you have like k to the power 33, so this solution doesn't work in this case. This is like a special case, so that's why I show you this solution, but this is not a general case. So that's why if you have a completely different equation, so you should use like Lambert W function or different thing. But exactly in this case you can work with a few tricks. This is the first trick. We just, in 2 parts, we just split our variables and our constant, and in the end we just get closer and closer, because we have absolutely similar structure on both sides. So that's why we just getting closer and closer to this same constant. We have 232, 464, 16, 128, and the last step we have 256 equal to 256. So yeah, this is my solution to this question. Also write your thoughts in the comments below. What do you think about this solution? Write your answer, write your response in the comments below. It will be really interesting to read about your solution. And of course, thank you for watching. Write your thoughts, write your solution. Maybe you have a geometrical solution from a geometric perspective. It will be really interesting to read about it in the comments below. And it's also really interesting to see your response, to see your feedback. And yeah, see you in the next videos. Take care of yourself and have a great day.